Good afternoon. Now we are going to see evolute and involute under differential calculus. The evolute and involute can be defined as the locus of the center of curvature of the given curve is called evolute. Evolute of the curve, the given curve is called the involute. Now we are going to see some basic curves along with their parametric equation because we are going to start the evolute and involute by using the parametric equations only. Okay. Now the parabola equation is given by, we know that very well. The standard equation of parabola is y square equal to 4ax and x square equal to 4ay in various directions. And the parametric equations are given by x is equal to 80 square, y equal to 280. This is we are already seen. This is the parametric equation of parabola. X square equal to 80 square and y equal to 280. Next, the standard equation of ellipse we know very well. This one is x square by a square plus y square by b square equal to 1 and its corresponding parametric equation is given by x equal to a cos theta and y equal to a sin theta. Sorry, b sin theta. And hyperbola equation is given by x square by a square minus y square by b square equal to 1 and its corresponding parametric equation is given by x equal to a secant theta, y equal to b tan theta. And the rectangular hyperbola standard equation is given by xy equal to c square and its parametric equations are given by x is equal to ct, y equal to c by t. The last one, asteroid x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3 and its corresponding parametric equation is given by x equal to a cos cube theta and y equal to a sin cube theta. Now, using this basic parametric equation, we are going to find the evolute of some standard basic curves. Before that, we have to give some basic procedure how to find the evolute. There are some procedures. The first one is first we can write the parametric equation for the given concerned curve. Whatever may be the curve, we have to write the parametric equation. The second step is, first step is to find the parametric form and the second step is to find y1 and y2. y1 and y2 is nothing but y1 is dy by dx and y2 is given by d square y by dx square. The third step is to find x bar and y bar. The previous session we are having the formula for finding x bar and y bar. X bar and y bar represents the center of curvature. And finally, we have to eliminate the parametric variable from x bar and y bar. That means, for example, in the case of parabola, the parameter is t. In the case of ellipse, the third parameter, apart from the Cartesian coordinate, we are having the third parameter is theta. In the case of hyperbola, also the third parameter is theta. Our aim is in the fourth stage, we have to eliminate the parametric variable from the given reduced equation. After eliminating the parametric variable, we are getting some reduced form of the equation which is nothing but our evolute. Okay. So first they are asking to find the evolute of the parabola y square equal to 4ax. Simply they are given that find the evolute of the parabola y square equal to 4ax. They are not giving the parametric equation. We must know the parametric equation of some basic curves. Then only we are able to start the problem itself. Okay. Now, the first step is what we are given already. Write the parametric form of the given curve. So the parametric form of the given curve, parabola, our given curve is parabola. Its parametric form just now we are seen in the table, x equal to 80 square and y equal to 280. Then the next step is to find y1 and y2. y1 and y2. That is y1 is dy by dx, y2 is d square by dx square. So y1 dy by dx can be written as dy by dx can be written as dy by dt by dx by dt. dy by dt by dx by dt. Why? Because we are writing this Arvina. Because here we are having the third parameter t. That's why we are not able to directly differentiate. If it is a Cartesian form curve, then I have to erase the board. So this is a third parameter we are having t, so we are not directly finding dy by dx. We can make some modification as dy by dx is equal to dy by dt, dy by dt by dx by dt. For that, first we need to find the value of dy by dt and dx by dt. We know that the parametric equation of the parabola is given by x is equal to at square and y equal to 2at. From this we can find dx by dt as dx by dt equal to a is a constant. What is the differentiation of t square with respect to t? We know that a basic simple formula x power n equal to n into x power n minus 1. So we can write it as 2 into t power 2 minus 1. That is 2at. Similarly, dy by dt is nothing but 2a into differentiation of t is 1. So here we can substitute all those things. Dy by dx is equal to dy by dt by dx by dt. Dy by dt is 2a by dx by dt is 2at. Then these two will be cancelled. We are getting simply 1 by t. The same manner only we are going to find d square y by dx square. The second derivative y2 equal to d square y by dx square. That d square y by dx square can be written as, usually we can write it as d by dx of dy by dx. But here we are having a third parameter t involved. That's why this term can be split into three parts. The first one is d by dx of dy by dx into dt by dx, okay, dt by dx. The next step, d by dt of dy by dx into dt by dx. We can split. This is no need to write. This is okay. Okay, d by dt of dy by dx into dt by dx. So d by dt of 1 by t, d by dt of 1 by t into dt by dx is nothing but dx by dt. We found that what? Dx by dt value is what? 280. So dt by dx its reciprocal can be written as 1 by 280. So d by dt of t inverse of 1 by 280. 1 by t can be written as t inverse. The next step, after making the simplification, we are getting y1 value is what? Y1 value is what? 1 by t, and y2 d by dt of t inverse 1 by 280. So we get y2 equal to minus 1 by 280 cube. Ordinary different cancellation. After ordinary cancellation, you are getting y2 equal to minus 1 by 280 cube. Next, we have to find the value of x bar by using the formula x bar is equal to x minus y1 by y2 into 1 plus y1 square. X is equal to 80 square. Y1 value is 1 by t. Y2 value is minus 1 by 280 cube into 1 plus t square. This step, because our y1 value is 1 by t, so y1 square is nothing but 1 by t square. So x value 80 square, and then we have to bring this into the numerator. It becomes its reciprocal as 280 cube by minus 1. So cancelling t, we are getting 280 square simply. And if here we have to take the LCM, or we have to multiply inside 280 square with the two terms, we are getting x bar minus 2a equal to 380 square. From this, we can find the value of t square as x bar minus 2a by 3a. Why you are making this arrangement means, our aim is to eliminate the third parameter, whether it may be t or theta. Our aim is to eliminate the third parameter in the fourth stage. For that purpose only, this equation can be modified by t square is equal to x bar minus 2a by 3a. The next step, we need to find the value of y bar by using the formula y bar equal to y plus 1 by y2 1 plus y1 square. So 2at plus 1 by minus 1 by 2at cube 1 plus 1 by t square. After making a simplification, we are getting y bar equal to minus 2at cube. That is y bar is equal to y bar by minus 2a equal to t cube. The first step, we found that the value of t square. The second stage, we found the value of t cube. Our aim is to eliminate the third parameter. Now, from the first and second equation, to eliminate t, we can raise the power as 6 in both the equation, taking cube on both sides. So t square whole cube is equal to x bar minus 3a the whole cube by 3a the whole cube. So t power 6 is equal to x bar minus 2a the whole cube by 27a cube. What is your aim is, we have both the equation in terms of t in the left hand side. One equation consists of t power 2, another equation consists of t power 3. If you are raising the first equation as a power 3 and the second equation as a power 2, we are having equally get the left hand side as t power 6. That is our aim. So first equation power can be raised by cube here. Second equation power can be raised by 2. Why? Because of the reason that we are getting t power 6 in both the equation of the left hand side. Then only we have to equate the right hand side of the both the equation. If the left hand sides are equal to each other, we can equate the right hand side of the two equations. Then x bar minus 2a, we can equate the right hand sides. X bar minus 2a the whole cube by 27a cube equal to y square by 4a square. And if you are cross multiplying, we are getting 4a square into x bar minus 2a the whole cube equal to 27a cube y bar square. In the final step, evaluate equation, we can remove x bar and y bar and we can simply write it as 4a square x minus 2a the whole cube equal to 27a cube y square. So the very first step is, we must know the parametric equation of the concerned curve, whether it may be parabola, ellipse or hyperbola, whatever maybe it is. We have started the problem by the parametric equation only. Next problem is, find the evolute of the ellipse x square by a square plus y square by b square equal to 1. For that, here the third parameter, in the previous case the parameter is theta. The current case the parameter is, in the previous case the parameter is t, current case the parameter is theta. Now the parametric equation of the ellipse, they didn't give in the problem, we have to write our own self. We must know all the parametric equations of the basic curve. Then only we have started the problem in the case of evolute. Okay. So x is equal to a cos theta, y equal to b sin theta. And taking the differentiation of x with respect to theta minus a sin theta dy by d theta is b cos theta. In the next step, dy by dx can be written as dy by d theta by dx by d theta. So b cos theta by minus a sin theta minus b by a cot theta. So y1 equal to minus b by a cot theta. Similarly, we need to find the value of y2. y2 can be split into three parts. y2 d square y by dx square can be firstly write as two parts and then it can be split into three parts. No need to write this step. Directly you can write this equation as d by d theta of dy by dx d theta by dx. So d by d theta of dy by dx value is minus b by a cot theta, just now we found, and dx by d theta we know that minus a sin theta, taking the reciprocal minus 1 by a sin theta. The next step, if you are taking the differentiation of minus b by a cot theta with respect to theta, b by a is constant, differentiation of cot theta is minus cosecant square theta. D by dx of cot x is nothing but minus cosecant square x. Minus of minus, it becomes plus here, and minus 1 by a sin theta. But we know that cosecant square is not, cosecant is the reciprocal of sine. 1 by sine is equal to cosecant. 1 by sine equal to cosecant. They are reciprocal to each other. Okay. So this can be written as y2 equal to minus b by a square sin cube theta. These are all the basic formulas that we are used in the step. These are all the trigonometric identities. Cos by sin cot, cosecant is the reciprocal of sin, and secant is the reciprocal of cos. Okay. Next we need to find the value of x bar, center of curvature coordinate x coordinate. X bar is equal to x minus y1 by y2 into 1 plus y1 square. So x value is a cos theta. From the parametric equation we can take. And then y1 by y2. y1 value is minus b by a cot theta. y2 value is minus b by a square sin cube theta into 1 plus y1 square. So a cos theta plus b by a cot theta into, if you are making the simplification here, you are getting minus a square sin cube theta by b into 1 plus b square by a square cot square theta. And then a cos theta into cot theta. Here 1a will be cancelled, b is also cancelled. Remaining we are getting minus a sin cube theta. 1a is remaining here. Minus a sin cube theta. Cot theta is there. The remaining bracket term is also there. Okay. So a cos theta, a sin cube theta, we can bring this minus here. Minus of cot can be written as cos by sin. A sin cube theta, the remaining bracket term as it is. The next step, a cos theta minus a sin, 1 sin theta will be cancelled. Minus a sin square theta cos theta is there. Okay. Into, if you are taking this a square sin square theta as LCM, then you are getting a square sin square theta plus b square cos square theta by a square sin square theta. And then a cos theta minus, here what are the remaining term we have? Cos theta by a, here one a is there. Sin square theta will be cancelled. Then cos theta by a, cos square sin square theta. How can they write this step? No need. This sin square theta can be written as 1 minus cos square theta. This b square cos square theta is as it is, we can keep. So a square minus a square cos square theta plus b square cos square theta. So from this we have to reduce the equation as, since using the concept cos square theta plus sin square theta equal to 1, previously we can write sin square theta equal to 1 minus cos square theta. This is a concern formula for that. Okay. A cos theta minus a sin square theta cos theta minus b square cos cube theta by a. In the next step, we can multiply a cos theta inside and we are cancelling these two. These two will be cancelled. A cos cube theta minus b square by a cos cube theta, taking cos cube theta outside, the remaining bracket term, taking a as LCM. A square minus b square by a is the value of the center of curvature x coordinate. And then from this equation we can write this as, we can bring this term into the left hand side. Ax bar by a square minus b square equal to cos cube theta. Next we find the value of y bar by using the formula y bar equal to y plus 1 by y2, 1 plus y1 square. Y value is b sin theta, 1 by minus b by a square sin cube theta. And then these are all already we founded value. Y2 value, y1 value, this is y value. So b sin theta, we can bring this into numerator, minus a square sin cube theta by b into this one. And the next step, we can take this as a LCM. If you are taking this as a LCM, a square sin square theta plus b square cos square theta by a square sin square theta into a square sin cube theta by b. And if you are making the simplification, you are getting y bar as sin cube theta into b square minus a square by b. We can take minus outside, minus sin cube theta into a square minus b square by b. These are all the very basic trigonometric simplifications. For that we must know the basic trigonometric formulas also. Then only we are easily simplifying the trigonometric issues. The next step, b y bar by a square minus b square sin cube theta. Taking whole power 2 by 3 and adding these two equations, we are getting a x a x bar power 2 by 3 by a square minus b square whole power 2 by 3 plus b y bar power 2 by 3 by a square minus whole square 2 by 3 equal to sin square theta whole power 2 by 3 plus cos cube. Why we are writing this now? Our aim is to making the right hand side as 1 and we are going to eliminate the third parameter theta because here the third parameter is theta. That parameter occurs only in the right hand side. For eliminating these two, the cube will be cancelled. Then sin square theta and cos square theta equal to 1. In the right hand side, in the step itself, there is no third parameter. Theta is not there. So simplifying, this is our required equation of evaluation.